All right, I forgot to write it up here. Page 8 and 9. Now, we talked in the previous lesson about taking like all the letters that make up a word, and to find out how many different ways those letters can be arranged, you count up how many letters and you do the factorial. So like water, W-A-T-E-R, right? We could take 5 times 4 times 3 times 2 times 1, and there's all those different ways we could rearrange those letters. However, if I take a word like banana, notice that I have 3 A's in there, and I have 2 N's in there, and they are non-distinct. N is the same as N, and A is the same as A, okay? So there's a little different thing we have to do to take out the fact that we have some repeated letters. We first count how many total, 1, 2, 3, 4, 5, 6. So we were going to do 6 factorial on the top, but then any that are repeated, like N shows up twice, so I'm going to do 2 factorial on the bottom. 3 is repeated 3 times, I'm going to do 3 factorial on the bottom. So the total number of ways possible, and watch this, 6 times 5 times 4 times 3 times 2 times 1. On the bottom, I'm going to do 3 times 2 times 1 times 2 times 1. So 3 cancels the 3, 2 cancels the 2. Of course, the 1's cancel out. I could cancel this 2 against this and have 2. All right, so the answer would be 6 times 5 is 30 times 2 is 60. Now, if you wanted to, you could multiply all those out, get a big number, and then multiply all of these out. Well, 3 times 2, 6 times 2, 12. Take the big number and divide by 12, and you would have the answer as well. So you can do either way. But we have taken into account now the fact that some of the letters are repeated, so that we have distinct ways of rearranging these letters. Let's take the word level. By the way, do you know how to tell if somebody is on the level? If their bubble is in the middle. That's a good dad joke for you, right? Tell your dad that one, see if he knows what it means. You know you're on the level if the bubble is in the middle. All right, here we go. Let's, how many possible letters? 1, 2, 3, 4. We have 5 letters on the top, so 5 factorial. But notice E is repeated twice, and L is repeated twice. So we're going to do 5 times 4 times 3 times 2 times 1. And then down here we're going to do 2 times 1 times 2 times 1. All right, so these cancel. This cancels against this. So it looks like I'm going to have 30 possible ways of arranging these letters, taking into account the fact that we have some repeated letters. There's a name for that. What is that called? Is it a palindrome or something, where the word is spelled the same way forward as it is backwards? Radar is another word like that. Off the top of my head, I can't think of others. All right, here we go. Before we started, I looked at my tray here, and it said I have 3 green markers, 2 black markers, 2 purple markers, and 1 red marker. How many total markers? How many total ways could I grab them and have unique combinations, okay? So 3, 4, 5, 6, 7, 8. I have 8 markers total, so 8 factorial. But then I need to do 3 factorial because I have 3 green, 2 repeats, so 2 black, and 2 purple. I don't need to worry about the 1 red, okay? So to find the answer, and I'm not going to do the math here for you, but we could do 8 times 7 times 6 times 5 times 4 times 3 times 1, and then divide by the 3 factorial, 2 factorial, 2 factorial, and you would have the answer of how many unique combinations I could pull from those particular markers. All right, looking here at page 9. So they have several, there's some big words, mathematics, characteristic, and then you just go back and count. So just first of all, on the top is how many total letters or numbers or flags or shirts or whatever. And then on the bottom, which ones are being repeated, and you do the factorial on the bottom and simplify. So the math is not hard, but like I said, this is very different from anything you have done before. All right, have fun with that.